Hey everybody, and welcome to the N Channel video blog. And today what I want to talk about is my final project as an engineer. Now, what I want to do before I graduate school is develop something to be actual variable speed drive. And how I want to do this is by varying the frequency. By exploiting a formula, it's quite an easy process. It's just actually developing the sine wave and the process of which it's powered to actually apply to an actual practical application with feedback that can actually control the systems of what it rotates at. That becomes an interesting process. So what my goal is right now is to actually do a step-by-step video of how I'm going to do this. And today what I want to do is just propose it. And I've already got it approved by my teacher, so I'm very excited about it because it's incorporating one of my major passions of actual woodworking. And what that allows me to do is use this to control the speeds of things I'm doing. So if I'm cutting, using the table saw, I can control the frequency. And because I live in North America, I have 120 volts, and most things draw under 15 amps. So I'm going to make it for that range. Something that can work on 2 horsepower potential. Most of my things are only 3/4 of a horse, so it's going to be probably more about 1500 watts, just so it's over-made. So that way I don't have to worry about damaging anything. And it just has the ability to last and go bigger if I needed to. So I'm going to go into a little bit of theory about how I plan to do this, but I really want to document the progression over a year of how I've actually accomplished this from the actual, just the rough design to the actual final product. And maybe if it actually works well, I'm hoping that I can post it on and actually get this to other people so they can use it. Not for their own project. I think you should work on your own and actually think about things you want to accomplish, but use it for a practical application and controlling such things. So as you can see in this graph I created, I've created a sine wave through a means of digital ability. And what happens is we're taking a digital wave and we're breaking it up into small portions. And in those small portions we have different voltages which replicate the actual stages of what would be happening at a sine wave. So if we do this enough, we can get a high resolution, which would mean that we have a very smooth actual transition of what a sine wave would look like. So by doing this, we're able to create a digital sine wave. Now all we have to do is feed that into a circuit which can actually amplify that signal and give us a higher voltage, and we can actually use this for practical application. So to actually determine the speed of which my motor will be turning at, we're going to be using this formula, which states that the synchronous speed of an induction motor is equal to 120 times F, which is the frequency, divided by P, which is the poles of the motor. So in the example below, what I said is that a 60 Hertz source divided by a 4-pole motor is going to give us 1800 RPM. Now if we change the frequency to 80, we'll have 2400 RPM. And as you can see, we have a really commanding way to actually alter the speed just by simply changing one of the variables in the formula.